Now we are going to start with the chemical properties of P block, but before we do that I just want to tell you that P block, the 17 group which we are talking about, it is actually very reactive. It is actually very reactive. So if we talk about their reactivity first, so it is that they are very much reactive. The reason being, they possess the low dissociation energy, and the second reason is that they possess high electron gain enthalpy. So these are the two reasons that make 17 group much reactive. So it's like that they have low dissociation energy. Now what does it mean? Low dissociation energy means, suppose we have a gas like say fluorine, we have a gas like chlorine. So we are saying that whenever they react with some other thing, this actually like breaking of this F2 bond, FF bond in F2 or Cl bond in Cl2, it requires less energy. So you must be thinking that why it requires less energy, because it is the group with the smallest size. As you all know, fluorine is the smallest of all in the periodic table. So that means those group members, fluorine, chlorine, bromine, iodine, they must be smallest in their in the period, right? But still they possess low dissociation energy. The reason being that like as we consider fluorine and fluorine bond, so what happened? They are small in size. So there are high inter-electronic repulsions. There are high inter-electronic repulsions. So that means the bond formed between them is not so much strong, and even the less means the lower energy can break this bond actually. So this is the reason that this group actually, the whole 17 group, they possess the lowest dissociation energy in the respective periods. And if we talk about single element, single molecule which possess the lowest energy, that is the fluorine one. The reason being too small, and being too small in size, there are much inter-electronic repulsions and the bond can be easily broken up, right? So this is what the reason for the more reactivity. Second is the high electron gain enthalpy. As you all know that they have electronic configuration near to the noble gas, they have Ns2Np5, and if they acquire one electron from outside, their configuration will change into Ns2Np6. So that means they will become stable. And we know that everything in the universe is just struggling for the stability. So that means they have a high electron gain enthalpy for the upcoming electron. But if we compare electron gain enthalpy of this period, this group actually in the whole periodic table, so they are going to possess the much negative electron gain enthalpy. But if we consider like in the group that we will be thinking that the fluorine will be having the maximum electron gain enthalpy, then it's not right. Out of fluorine and chlorine has the highest electron gain enthalpy. The reason being fluorine is too small, so the incoming electrons suffer much repulsions. So that is why it has less affinity for the incoming electron. And if we compare fluorine, chlorine has high electron gain enthalpy, because its size is sufficient that an incoming electron do not encounter such kind of repulsions, and it can easily accommodate that electron. So this is what are the two reasons behind the much reactivity of the halogens. The one is they possess the lowest dissociation energy in their respective periods, and in the group fluorine has the lowest one, and even in the whole periodic table fluorine has the lowest one. And second is the high electron gain enthalpy, because after acquiring an electron they will attain a noble gas configuration, and this is what they want actually. So this is the reason that they are very much reactive. Now taking into consideration the another property, that is the oxidizing power. Oxidizing power. So we'll see that they are actually a powerful oxidizing agent. They are powerful oxidizing agent. What is oxidizing agent? We know that oxidizing agent is that which can oxidize other. That means it can actually like for example it combines with sodium. Sodium has a power to donate electron, and chlorine has a power to gain electron. So as chlorine has the power to gain electrons, so that means by gaining it can oxidize sodium, because sodium is going to lose only when there is some other element which has a great affinity for electron as compared to the sodium, and that is the chlorine. So that means because they have high electron gain enthalpy, as we already discussed, so that is why they are powerful oxidizing agent. So like what happened, like they are present like this. They gain an electron, and after gaining an electron they become the negatively charged ions. So that means they possess a high electron gain enthalpy and they readily form the anions. So if we talk of oxidizing power first, so that means this group has a maximum oxidizing power because it has the highest electron gain enthalpy in the whole period. That means much less much negative value of the electron gain enthalpy. So if we consider fluorine, chlorine, bromine and iodine, so we will see that fluorine is a stronger oxidizing agent than chlorine. So it cannot, chlorine cannot displace fluorine, but fluorine can displace chlorine. Chlorine is a stronger oxidizing agent than bromine. Chlorine can displace bromine, but bromine cannot displace chlorine. Likewise, bromine is a stronger oxidizing agent than iodine. It can displace iodine, but iodine cannot displace bromine. So that means we will see that along group when we move, oxidizing power decrease. Oxidizing power decrease, right? So you must be thinking that why it decrease, you know that reason, because as we are moving down, electron gain enthalpy is becoming much less negative. It is becoming less negative. It is highest for the fluorine one. Like if we compare fluorine, chlorine is going to possess the highest electron gain enthalpy, right? And the second will be fluorine and then bromine and then iodine. So that means for iodine it is much less negative. So that means due to bigger size, that means it possesses lesser oxidizing power as compared to the upper members. Now the question is this, as I have told you that fluorine, we know that, I will write here, we know that fluorine is smallest of all and chlorine is quite bigger than fluorine. And if we talk of electron gain enthalpy, it possesses less electron gain enthalpy and chlorine has highest electron gain enthalpy. So you must be thinking that as we discussed that oxidizing power means the element with higher electron gain enthalpy is going to be a powerful oxidizing agent. So you must be thinking that chlorine will be a much or you can say most powerful oxidizing agent in this group. But it is not like that, it is the fluorine one only. The reason being, see, whenever we are considering the oxidizing power, it depends upon three properties. Like the three steps is included in the oxidizing power. One is the conversion of molecule into anion. Second is molecule into atom. And for this we need to give bond dissociation energy. And this energy is given, so I will write plus delta H because it is being absorbed. Second is that conversion of atom gains an electron and it forms the anion. And it includes electron gain enthalpy and this is the energy which is given out. So that means minus delta H. Then this anion get hydrated, right, and it release hydration plus water, hydrated, and it releases the hydration energy. Again it is being released. So that means oxidizing power is favored when you can say that dissociation energy is, I will write here, this should be low, this should be high, and even this step should be high. So that means absorption should be less, that means the energy which we supply from outside should be low, and comparatively the energy which are released actually in second and third step should be high. So we see that this is maximum in case of fluorine but not in case of chlorine. So this is the reason that fluorine is the best oxidizing agent, being though it possesses the less electron gain enthalpy, but still it is a powerful oxidizing agent because energy released in second and third step is much higher than the energy absorbed in the first step. And if we compare it with the chlorine, the sum of the energies which are released is comparatively low as compared to the energies which are released in the case of fluorine. So this is the reason that though it is having a higher value of, the lower value of electron gain enthalpy, but still it is a best oxidizing agent, right. So this is what about the oxidizing agent. I think you can answer it in a proper manner if somebody asks you or if you get a question about their oxidizing power. Next property we are going to discuss is reaction with metals. Reaction with metal. We see that whenever metal react with any halogen, this can be chlorine, bromine, iodine, right, or fluorine. Whenever metal react with halogen, it forms the metal halide. It forms the metal halide. For example, I have Na, I am going to react with Cl. So you know that NaCl is our table salt. So that means they form their respective halides. They form their respective halides. And we see that these halides are actually ionic in nature. these halides are ionic in nature, but reactivity, or if we talk about the ionic nature or reactivity of stability of the halides, we see that MF is much stable than MBr, MCl, which is much stable than bromine, means bromide, and less iodide is the least stable. And also if we talk about the ionic nature, ionic character decreases down the group. Ionic character decreases down the group, because we see that metal is going to remain of same size, but here fluorine is smaller, chlorine is quite big, bromide is quite big, iodine is quite big. So that means there will be a polarization effect also, and due to which the ionic character will decrease as we move down the group. And moreover, we have seen that whenever the halide is present in higher oxidation state, like for example SnCl4, PbCl4, we see that they are actually covalent in nature. But when they are present in lower oxidation state, like SnCl2, PbCl2, they are much ionic, or you can say less covalent as compared to the SnCl4. So we will say they are less covalent in nature. Right, so this is what about the halides, and I think it's clear that whenever they react with metal, they form their respective halides. Can be metal chloride, can be metal bromide, can be metal iodide, and as we talk about as we know that they form an ionic bond, and ionic character just decrease down the group, because we know that there come an effect of polarization where the anion is bigger and cation is smaller, so they have that phenomena, polarization operating between them, and that is due to that the ionic character slightly decrease, and there is an introduction of the covalent character also. And moreover, we see that whenever the halides are present in higher oxidation state, they are covalent, and when they are present in less oxidation state, they are less covalent, or you can say they have an ionic character in them. Third property we are going to discuss is reaction with non-metal. They react with non-metal forming a covalent bond. For example, P4 plus Cl2, it forms PCl5, and likewise we have As arsenic plus chlorine, it forms AsCl3. So likewise we have many many reactions in which the halogens combine with non-metal forming their respective halides, and those halides are actually covalent in nature, purely covalent. Because we know that non-metal and non-metal always forms a covalent bond, there is a mutual sharing, right. So this is what is the reaction with the non-metals. So I think you are clear with the reactivity, with the oxidizing power, with the reaction with metals, with the reaction with non-metals. Now we will start with the further more properties.